In this video, we are going to discuss about the difference between the cache memory and the virtual memory. So the first difference is in the cache memory, already we are bringing the recently used or frequently used data from the main memory into the cache memory. Therefore, we can increase the data access time. Whereas in the virtual memory, uh, we are virtually increasing the size of the RAM. Okay, by bringing the by considering the temporary storage as a main memory. The second difference is for this one, the CPU and other related hardwares will control the cache memory, whereas the operating system OS will control the virtual memory. This is in terms of the replacement algorithm and mapping technique. These are required, right? And you can see generally the cache memory size is very less compared to the main memory, whereas in the virtual memory the size is more, because it is a temporary memory. The size of the temporary memory is generally it is more compared to the main memory. The fourth difference is the cache memory will hold the data which is recently used by the CPU, central processing unit, whereas in virtual memory it holds the data which cannot be accommodated inside the main memory. So the next difference is since the cache memory is expensive because we are using complex hardwares, and we have to access the data very fastly. Therefore, it is very expensive. Whereas in virtual memory, it is less expensive. So generally, we use cache memory in order to improve the CPU efficiency. If you use in virtual memory, since if you use temporary memory means it will generally the access time from the CPU to the secondary memory is generally it is very slow. Okay, so it will slower the performance. And the next difference on the last difference is in cache memory we use complex hardwares, right? It is very bit complex. Whereas in virtual memory, it will prevent program crashes, because everything must be comes into RAM, right? So if RAM is full, uh, uh, RAM is full, and if it is not able to accommodate the data which is sent by the user, means the program will automatically get crash. So in order to avoid that crash, we are going for the virtual memory. So it will prevent the program crash in our system. Where is the cache memory is located? For that one, you go to the controls panel, and from the control panel you choose advanced system setting. In the advanced system setting, you go to performance. Okay, so in the performance you see in the advanced tab, you will get virtual memory. So like this, you can search it for any other systems also. Likewise, in order to see my cache memories, you press Control plus Shift plus Escape. Okay, so you will get a task manager. In the task manager, you click the performance tab and select the CPU from the left hand menu. So at the bottom right of the window, you can see the size of the L1, L2 and L3 caches for the corresponding systems. So next we will discuss about virtual memory. So it is nothing but a memory management technique where the secondary memory can be used as if it were a part of a main memory. So it uses both the hardware and software to enable a computer to compensate for the physical memory shortage temporarily, transferring a data from RAM to the disk storage. here the address which is used by a programmer will be called as virtual address, and the set of such addresses are called as address space. And addresses in the main memory is called as a location or physical address. The set of such addresses is called as memory space. So in the memories, you can see the address space is always greater than the memory space. So the memory management unit, MMU, is used, which is nothing but a memory management unit which is used to convert the virtual memory address into a physical memory address. Virtual memory is a temporary memory used along with the main memory of the system. So it allows the user to use more memory for the program than the real memory of the system. Consider this is a processor, and you have a main memory and auxiliary memory. Here you can see the main memory is of 32K size, and the virtual memory n is equal to 1024K. So this I can write as 2 power 20 and 2 power 50. So here you can see the virtual memory space is divided into equal size of blocks, which is called as pages, and the primary memory space, that is main memory, is also divided into equal size of blocks, which is called as page frame. So here the pages are loaded from the virtual memory to any available page frame of the physical memory. So whenever the page is needed, the parser will check for the desired page which is present in the physical memory. So if it is found, then it is called as hit. Okay. If the desired pages is not present in the physical address, this is called as miss or page fault. Okay. So whenever the page fault does occur, so the desired page is loaded from the virtual memory to the primary memory. Okay. So if there is no empty page frame is available in the physical memory, then we have to use a page replacement technique. So what is a page replacement technique is the old page in the physical memory is replaced by the new desired page from the virtual memory. So there are popular algorithm which is available. One is FIFO, LRU, LFU, and optimum methods. Okay, which will determine which page from the physical memory must be replaced. Suppose we are copying the page from the virtual memory into the main memory, and we are modifying the data. And if I want to replace the data from the main memory so you have to copy the replace data from the main memory into the virtual memory, then you have to copy. Okay. So next we will discuss about crashing. So if there are too many page fault occurs, then the system is said to be crashing. So this must be avoided. Okay. So next we will discuss about here you can see the address space which is divided into 1024 pages, and the main memory is divided into 32 block, that is also called as page frame. Okay. So here the 1K is common. So the pages of page 0 is of 1K memory, and page frame is also of 1K memory. Okay. So next we will discuss about the topic called dirty bits, dirty bit or percent bit. So the dirty bit is checked in order to determine if the page is modified in the physical memory. Okay. So if the dirty bit is 1, then the page has been modified, that is it is dirty. Hence, it must be copied back to the virtual memory before being replaced. Else, the modified information will be lost. So, if the data bit is 0, then there is no problem. And we can easily copy the pages from the virtual memory into the main memory. So, since we can any page of the virtual memory can be loaded into any page frame of the physical memory, we are using a page table, which is required to give the mapping between the virtual memory page number and the physical memory page frame number. So, and this is my physical or main memory. Okay, into a fixed block size. So this is called as page, and this is called as block, which is of fixed block size of 1K, because you can see total memory space is 2 power 12. 2 power 12, I can write it as 4K, that is 2 power 2 into 2 power 10, and the address space is n is equal to 8K, that is 2 power 13, that is 2 power 10 into 2 power 3. So 2 power 3 means 0 to 7, 0 to 7, and 2 power 2 is from 0 to 1. Okay. So each page is stored in the in any available page frame. So if any page frame is free, the page can occupy in the page frame. Okay. So you can see the address space and the memory space are split into a group of 1 kilo words. So each of 1 kilo word size. Suppose if the pass there is a CPU, sends a virtual memory, virtual address. The virtual addresses consist of page number and line number. So the line number is also called as offset. Okay. So the offset is 1K, that is 2 power 10. So you have 10 bits for the offset, and it consists of page number. So the page number is it will go to the virtual memory. So it will check for 0 0 to 111, and so and the page, from the page number, it will goes to the corresponding page table. It goes to the page table. The page table consists of page page number. This is my page number, and this is my page frame number. So the one represent it is present inside the main memory. So since it is present, it will convert that one into a physical memory. So it consists of page frame number, this page frame number, and the line number. The line number same for the physical address also. So it will goes to 0 1. So 0 1 is here, right? 0 1 is here. So it will so the CPU will access this block one. Okay. So it will be a time consuming process. Therefore, I am going for the translation lookup buffer. So it is nothing but a high speed cache, which is used by the memory management unit in order to store the recent transaction of the virtual address to the physical address. So the CPU generates the virtual address, and the memory management unit will convert the virtual address to a physical address. So how it will convert means it will go to the TLB. Okay, first it will go to the TL. Okay, so it consists of the recent transaction, recent translation. So if it is there means it will directly. So this TLB consists of the page number. So the number will convert into page frame number. So it will directly access the main memory. So it will be very fast. Okay. So if it is hit, it will directly convert this one into a physical address. Okay. So it will not look into the page table. Okay. So the TLB will remember the recent page table lookup so that the CPU doesn't have to access the page table in memory every time. Okay, so it will not go to the page table. So whenever the CPU want to access the memory location, the CPU will generate the virtual address. The memory management unit that check the TLB. So in order to see whether the page number is present, so if it is present, the page frame number is taken from the TLB and it will be a fast access. Okay. So if it is not found, so it is called as miss. Okay. So if it is called as miss, so the memory management unit will look up for the page table. So if it is a miss, it will go to the page table. Okay. If it is a miss, so it will go to the page table. In the main memory in order to find the page frame number. So once if the page frame number is found, okay, page frame number is found, then it will follow this step. So, so after the TLB means the TLB also get updated with the new mapping for the future use because it is a recent transaction, no? So the recent transaction will store in the TLB. So what is the structure of the TLB is? So it consists of the virtual page number, that is page number, and with page frame number, that is uh, uh, physical frame number, and it consists of a valid bit which indicate the entry is valid, and the protection bit. So it is give the permission for the read, write, and execute operation. Then it consists of a reference bit which is used for the replacement policies. So what is a memory management unit? So memory management unit is a hardware component which is a part of the CPU or placed close to it, which will handle all the memory and the address translation tasks. So the memory management unit will convert my virtual address generated by the CPU into the physical address which is used by the main memory. So what is the function of the main memory unit is address translation conversion, that is from virtual address to the physical address using a page tables and the TLPs. And it will give you protection, which is ensure the process can only access its own memory and it prevents the illegal memory access. Next one is catching TLB entries. It keeps the recent address translation in the TLB in order to speed up the translation. Then it will provide memory sharing, that is allows the multiple processes to share memory safely. Next, it will page fault handling support. That is generate a page fault interrupt if a page is not present in the memory. Then it supports for paging and segmentation, which that is it handles both segmented and page virtual memory system. So next one topic is demand paging. Demand paging is called as a memory management technique which is used in the virtual memory system, where a part of where pages of programs are loaded into main memory only when they are needed during the execution. It is not, that is, it is not stored in advance. So in a system which is using a virtual memory, the logical address space of the process is divided into a fixed size block which is called as pages, and the physical memory is divided into frames of same size, which we have already discussed. So in demand paging, when the process is started, only a few pages are loaded into a memory. When the CPU tries to access a page which is not present in the memory, the page fault will occur. On the operating system, it will fetch the page from the secondary storage into a free frame in a RAM. What are the steps in demand paging is the CPU generate characters which divided into page number and offset. So the memory management check if the page is there in the main memory. If it is present, it proceed normally. If it is not present, page fault will occurs. So how the OS will perform is it will find a free frame and it reads the required page from the disk into that frame and update the page table to mark the pages present. Okay. So the CPU instruction which causing the fault is restart. So that's all about the video. I hope this video is useful for you. Thank you.